Today's topic is dielectric loss. Dielectric loss. So what is actually a dielectric loss? It is the loss during signal transmission. Signal transmission, when you are transmitting a signal by means of some electromagnetic wave, the loss occurred is called a dielectric loss, and the loss is expressed by means of something called tangent loss. Why is it called a tangent loss? Because it is expressed as tan delta, which is a ratio of two quantities, epsilon prime and epsilon double prime. Okay. Epsilon double prime by epsilon prime. So this is also called a tangent. So what is this epsilon prime? Epsilon is the permittivity. Is the permittivity. What is actually permittivity? It is ability to store energy. यदि हम लोग कोई डायलेक्ट्रिक मटेरियल लेते हैं, dielectric we are talking about an insulator. This is a dielectric. Or when we allow it inside an electric field, so the property of this material, it allows some part to go away and some of its energy is stored inside the material. So that part which is stored, it is called permittivity. Like it is not so simple, because whenever we are saying electric field, it's not that always a DC electric field is there. It can be an AC electric field as well. Alternating current. तो alternating current है तो उसमें क्या हो गया? Associated with the frequency. Now, when we are allowing this sort of electric field of the alternating current to pass through, then you can need to express the permittivity as a combination of the real part and the imaginary part. Okay. तो पहले जब लोग बोल रहे थे एनर्जी स्टोर्ड, now they will have two parts, where the real part, that is the real, this is complex, real part of permittivity is epsilon naught, which is the energy stored. So, this is the energy loss. Excellent. So this is the energy stored. And this is the energy lost or dissipated. Energy loss and energy dissipated. Now, if we take vacuum, vacuum case में कोई energy loss नहीं होगा. So in the vacuum, we represent the permittivity as the epsilon 0. In the normal case, we represent normal material. We represent a term called epsilon r. It is the ratio of and this is called the relative permeability. Or it is also called the dielectric constant. Okay. नहीं बने ठीक है. In the case of vacuum, this epsilon r, क्या होगा? It will be epsilon 0 by epsilon 0 is equal to 1. In the case of air, the relative permittivity, it is almost equal to 1. Water के केस में this is about 80. और दूसरा एक क्वांटिटी है इसको हम बोलते हैं FR. FR is a fiber optic material used in printed circuit boards. इसमें relative permittivity is about 4.2 to 4.6 is ratio. ठीक है. अच्छा, now what actually it is being, ये तो हमने समझ में आया. लेकिन इसका what is the practical manifestation of energy loss? Practical manifestation है heat generation. So there is some sort of heat generation हो रहा है due to the energy loss. कैसे हो रहा है? So for that we need to understand another quantity which we are calling it as P. P vector is called polarization. ठीक है, चलो बाद में मैं बोल देता हूँ. टुडे वी आर डिस्कसिंग डाइलेक्ट्रिक लॉस. That is loss that occurs when we are transmitting a signal, and when the transmission of signal is through a dielectric, which is also called an insulator. So we see that there is some sort of loss taking place. That loss is due to this quantity, is called tangent loss. It is the ratio of two quantities. One is the imaginary part of the complex dielectric constant, और दूसरा है the real part of the dielectric constant. All of it. And these are the things you already know. Perhaps in freeze in vacuum we have this is absolute. उसके बाद we have this relative permeability. This is permeability of free space fluid. It is more medium. Then we have relative permeability with respect to, and we have dielectric constants like here. अलग-अलग क्वेश्चन के relative permeability. So, FR is a fiber optic medium used in printed circuit boards. कोई भी किसी भी प्रिंटेड सर्किट बोर्ड को इफ यू पुट इट इनसाइड वाटर क्या होगा? खराब हो जाएगा. मतलब जो फ्लो ऑफ करंट जिसमें से जा रहा था somehow it will get hampered, और all of these are वहाँ पे heat generation. So there are two things. One is heat generation, and secondly the flow of current is getting disturbed. आपको कॉन्सेंट्रेट करना है दो क्वांटिटीज के लिए. वन इज ओमेगा और दूसरा है पी. ठीक है. पोलराइजेशन, व्हाट डू यू मीन बाय दिस इन सिंपल टर्म्स? Polarization means arrangement of positive and negative charges. It is a dielectric, but there are two types of charges presented, positive and negative. Now, when we are supplying an AC electric field, that means the poles are constantly changing, plus minus plus minus. तो एक DC में जो polarization होना चाहिए था, AC में इट विल शिफ्ट, राइट? पोलराइजेशन भी शिफ्ट करेगा with the frequency of the AC. Now if we increase, keep on increasing the omega. Polarization को भी if it wants to be at par with the change in the frequency, इसको भी उस तरह से change करना चाहिए if it wants to stay with that, लेकिन it is unable to do it because of the different frequency range. I'm going to the next slide. अच्छा, इससे पहले did you get all my what I've sent in WhatsApp? अच्छा, जो आज सुबह मैंने भेजा है उससे पहले देखो, I've already sent you one more thing जहाँ पे lectures सारे सबका HTML है क्या? Electronic and magnetic materials. Electronic and magnetic materials. देखा? उसमें click on the first one. Array code. Then array this way. ठीक है? Array. Some number, how would I do the right? You see how it is?
Material stores electrical energy in a field of empty space does. That storage happens because a field displaces bound charge. 4 mechanisms do the work. Electronic polarization ships an atom's electron cloud away from its nucleus, and it is fast enough small scales all the way up to frequencies. Ionic polarization matches the positive and negative ions of the crystal.
ठीक है, stop कर लो. I'm just trying to explain it. So it says that polarization are 4 types. One is space charge, दूसरा है ओरिएंटेशनल, तीसरा है आयोनिक, चौथा है इलेक्ट्रिक. These are the 4 P's. और मैंने क्या कहा था? We will concentrating on a quantity which is called the omega. What is omega? It is the frequency of the AC. Now electromagnetic spectrum, तो अगर शुरू से नीचे की तरफ देखो तो you can categorize the EM spectrum into basically 7 different classes. Radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays, gamma. So now when when we are applying an electric field, AC electric field, through dielectric material, these four different types of polarization will take place. First of all is the space charge polarization. What is the space charge polarization? So if there are some ions or electrons as a defect inside the material, they will migrate, they will move based upon the frequency, unless they hit a boundary. और जैसे मैं इसको रिवर्स करता हूँ, they will again go back in the back direction unless and until they are hitting another point. So this boundary to boundary movement ये चलता रहता है. अच्छा, ये जो frequency इस रेंज में जो चलती है, it is between at very low frequency, 10 to the power -3 से इस रेंज, ठीक है. तो इट इज इन दिस रीजन. देन वी गो टू ओरिएंटेशनल पोलराइजेशन. ओरिएंटेशन पोलराइजेशन होता है, फॉर एग्जांपल इन द केस ऑफ वाटर. इसको का स्ट्रक्चर कैसा है? वी हैव ऑक्सीजन, वी हैव हाइड्रोजन, यहाँ पे there is delta plus and delta minus charges. तो dipole moment create हुआ है यहाँ पे. जैसे जैसे मैं फ्रीक्वेंसी चेंज करता हूँ, ऐसे वैसे मेरा डायपोल चेंज हो रहा है. ये एक्चुअली मेगा में इतना चेंज है ना. ओके, एंड मान लो आई हैव गिवन फ्रीक्वेंसी, देन आई हैव रिमूव्ड इट. सो व्हाट विल हैपन? Applied and removed. So in this case, molecule comes back in the random state. Molecule comes back in the random state, and the time taken for the molecule to come back to its random state is tau. This tau is called the relaxation time. माइक्रोवेव तुम लोग ने सबने यूज़ किया है माइक्रोवेव, उसमें गर्म कैसे होता है ना? नहीं, पार्टिकल भी ऑब्जर्व नहीं करता। माइक्रोवेव मतलब ये टीवी माइक्रोवेव, ये वाला फ्रीक्वेंसी हम लोग दे रहे हैं। खाने में क्या होता है बेसिकली? वाटर होता है। तो वाटर का इट हैज गॉट अ सर्टेन डाइपोल मोमेंट। तो माइक्रोवेव हम लोग जैसे दे रहे हैं तो इट चेंजेस द डाइपोल मोमेंट विद द फ्रीक्वेंसी। ठीक है, अगर मान लो मैं माइक्रोवेव की जगह पे रेडियो वेव यूज करता हूँ, क्यों नहीं होता? बिकॉज फॉर द चेंज इन द डाइपोल, अच्छा मैंने फिर से मान लो इट हैज ऑलरेडी रिलैक्स, देन आई एम अगेन सप्लाइंग द, क्योंकि बार बार चेंज हो रहा है तो इट इज क्रिएटिंग अ फ्रिक्शन, एनर्जी लॉस होता है ना। दैट एनर्जी लॉस is what is the heat generation. तो मुझे एग्जैक्टली ये वाला फ्रीक्वेंसी क्यों चाहिए? बिकॉज दिस इज द फ्रीक्वेंसी एट विच द डाइपोल्स आर एबल टू चेंज। मैं अगर बहुत ज़्यादा फ्रीक्वेंसी दूंगा तो मतलब उसके चेंज करने से पहले ही पोलराइजेशन चेंज हो जाएगा। ओके, सो दिस टाउ and this omega, they have to be an equilibrium. What is that equilibrium? Equilibrium is omega into tau is equal to 1. ठीक है, अगर मैं रेडियो वेव यूज करता हूँ, ठीक है, रेडियो वेव में फ्रीक्वेंसी इज, and that is omega tau is the relative frequency is higher. Omega tau is more than 1. It will not work. And if मैं अगर visible light use करता हूँ, in that case omega tau is less than 1. That will also not work. So I have to be exactly, I think it's 2.4 gigahertz इस रेंज में होता है। Just check it once. The frequency कितना होता है? So around this frequency the microphone actually works. तो यहाँ पे what we are getting it, so it fails. It is valid up to a certain frequency range, but it fails above microwave. इसका जो ऑपरेटिंग रेंज है that is you can say that it is 10 to the power 3 to about 10 to the power 10. इस रेंज में काम है, ठीक है। So in all these cases we are having a loss. You tangent loss के बारे में बोल रहा हूँ, tan delta. In all these cases we are having a loss, but it is frequency dependent. कौन सा किस रीजन में होगा? अच्छा, इसको लोग डिस्पर्शन भी बोलते हैं। Also recognized dielectric डिस्पर्शन। जब भी फिजिक्स या किसी भी जगह तुम लोग देखोगे तो डिस्पर्शन का मतलब है चेंज विद रिस्पेक्ट टू फ्रीक्वेंसी, दिस इज कॉल्ड डिस्पर्शन। सो दिस इज आल्सो अ डायरेक्ट डिस्पर्शन, ठीक है। तो एक हो गया स्पेस चार्ज बिकॉज ऑफ द फ्री आयंस और इलेक्ट्रॉन्स इन्वॉल्व। सेकंड हो गया ओरिएंटेशनल बिकॉज ऑफ द कॉमन डायपोल्स, कॉमन डायपोल्स। थर्ड हो गया आयनिक। आयनिक मतलब पॉजिटिव आयंस और नेगेटिव आयंस जो आयनिक क्रिस्टल्स में रहते हैं, दे एक्चुअली चेंज द पोजीशन। इसका भी रेंज है, it is allowed 10 to the power 10 to 10 to the power 13 hertz. And the last one is the electron cloud. Basically, we are talking about cloud surrounding इसमें शिफ्ट है. This can actually be a very high range, 10 to the power 13 से 10 to the power. So हर एक स्टेप में there are some polarization loss is taking place. लेकिन मालूम what about the space charge and the radiation polarization जब इस frequency में हम लोग हैं तो they are actually inactive because उतना fast उनके लिए as if they are not able to cope, they lag behind. So whenever the frequency is too high, frequency अगर बहुत ज़्यादा high हो गया है and the molecules are not able to orient themselves in either of the ways, तो उसको हम बोलते हैं lag. Well, they are not affected. अलग अलग केस में अलग अलग फ्रीक्वेंसी के लिए अलग अलग lags. ठीक है. Okay, it's clear to this. Next thing is this. ये जो एक्सप्रेशन there is something called alpha S and there is something called alpha S is when we are saying that there is no loss. And alpha frequency is when so saturation बोलते हैं, one of them is called the saturation. Maximum response. Maximum response. The molecules are able to match molecules can cope with changing conditions. The molecules completely lag behind. Here is the two terms. अच्छा now ये जो थ्योरी दिया था डायइलेक्ट्रिक लॉस का, इट वाज गिवन बाय डिवाइस. Now, what is the problem with device theory is that उसने एक hypothetical ideal material consider कर लिया था. Device theory में the problem was to consider any material to be ideal. मतलब अगर चेंज हो भी रहा है तो सारे इन एवरी पार्ट ऑफ द मॉलिक्यूल इज बिहेविंग इन द सेम वे, बट ऐसा होता नहीं है रियल वर्ल्ड में, रियल मटेरियल्स में। डिफरेंस इन स्ट्रक्चर होता है। So even if there is some relaxation, there is some polarization taking place, that will be governed by a certain structure. तो इसको find out करने के लिए, but suppose we would like to know what is my epsilon s and epsilon infinity of any random molecule. ठीक है, तो उसके लिए दो चीज़ इंट्रोड्यूस किया गया था. One was introduction of a parameter called alpha, which is called a modifier. And alpha was always greater than 0. If alpha is equal to 0, that means there is no loss for the alpha is equal to 0. And this theory was given by Cole. कोले नहीं है, स्कोल बहुत लोग सब कोले बोलते हैं, कोले पर स्कोल प्लॉट कुछ नहीं है. कोल प्लॉट इज द प्लॉट epsilon double dash with epsilon dash. This is a plot. This is also called plot. Now if it is an ideal material, अगर डिवाइस ideal material है, तो in the code plot it gives you an exact semicircle. जिसका कि सेंटर होगा on the axis. ठीक है, this is what लेकिन अगर आइडियल मटेरियल नहीं है तो क्या होगा? तो इट विल बी बिलो द हॉरिजॉन्टल एक्सिस. बिलो द हॉरिजॉन्टल एक्सिस मतलब आई विल गेट अ सिमिलर सॉर्ट ऑफ कर्व, और इट विल बी, मान लो इट विल बी तो इसका जो सेंटर है वो यहाँ है. Also there will be a shift. So first of all there will be a downward movement, और दूसरे साइड there will also be a shift either in this way or in that based upon the combination. तो जिस पॉइंट पे आके it is cutting the first cut of the horizontal axis, this is your epsilon sigma, epsilon infinity, and when it is cutting this one, this is your epsilon s. ठीक है.